I'd like to introduce you to Dr. Brian McVicker. Dr. McVicker is the co-director of, and I'm going to try to pronounce this, so you're going to have to probably correct me here, but please.
The Javad Moffagan Center for Brain Health.
I would not have gotten
He was a very generous donor who gave us a large donation to complete the building.
Okay, yeah. So, can you pronounce that again?
Javad Moffagan.
I'm going to try to get that right next time we do one of these. Well, in addition, Brian holds the Canada Research Chair in Neuroscience at UBC and is a professor and head basic neuroscience in the Department of Psychiatry. He's also a fellow of the Royal Society of Canada and a fellow of the Canadian Academy of Health Sciences, and until recently was the director of LeDuc, does that sound? LeDuc Foundation, a transatlantic network of excellence on the regulation of the brain's vascular energy supply. So, as you can imagine, we are now narrowing down to a little bit more specialized work. And so the first question I have for you today, Brian, is this. You are the director of the Center for Brain Health. What is the CBH, and why did you call it the Center for Brain Health?
So the Center for Brain Health, it represents kind of the future of integrated neuroscience, and it has made a splash. It's about a year and a half old, and it's getting around the idea there's a separation between psychiatric diseases, which are more exemplified by depression or schizophrenia, mental illness, and diseases that you would go to for neurologists, such as maybe Alzheimer's or epilepsy. There's a recognition now in the field and in the people who study the brain that these are all diseases of the brain. There's no separation between controlling behavior to a certain extent and controlling memory or recalling memory. Is that to truly understand how to treat the brain, we have to treat it as a whole. And so the center has psychiatrists, neurologists, rehabilitation people, basic science such as myself. I'm not a clinician. I study how the brain works and how diseases develop. But I think it helps maybe to get around the stigma, is that diseases that were maybe people are very comfortable talking about in the past, mental illness or depression, it does reflect a change in the brain, and we're trying to understand this. And it does take a coordinated effort. I think discoveries nowadays, it's a team sport where you need lots of different approaches. Looking at the genetics, the imaging you heard about from Fiona, and this is a way to make inroads in how to treat these terrible diseases.
Well, speaking of the imaging, for instance, how does the brain work? I'm a novice at this one, I wouldn't know, so maybe you can
So this is a little chance to explain a little bit, Neuroscience 101. I know there's a lot of different backgrounds here, and so the brain consists of what are called nerve cells, and these communicate by electricity. Little electrical impulses are generated by nerve cells and transmitted down the axons. And the brain has 100 billion nerve cells, more cells than there are stars in the galaxy. So the complexity is extraordinary, and each of these cells has maybe 10,000 connections. So another point is the connections. It's electrical communication, but it's also chemical. Each connection, called a synapse, releases a neurotransmitter, or a chemical, that then causes an electrical impulse in the next cell. And so this is why often diseases such as depression or mental illness are considered chemical imbalances, because people are talking about the control of the chemical communication between nerve cells.
Well, what do you mean by, say, dementia, depression, or brain diseases? Then? How would you?
So I would, you heard of some great descriptions earlier today from Fiona, and I would separate a bit more. There's Fiona did touch upon the impact of brain diseases, and there's another great statistic from the World Health Organization. Look at the impact of brain diseases, and this is the philosophy. We're talking about mental illness, we're talking about depression, we're talking about neurodegeneration, all these together. This is the biggest #1 impact in society nowadays based upon disability impact. And number one is depression. Number two is neurodegeneration. So neurodegeneration, this reflects when often the cells are actually dying. The nerve cells in a form of neurodegeneration called Parkinson's, this is a movement, a loss of control of movement. These cells in a very small area of the brain called substantia nigra, way down the base of the brain, are starting to die, and then you start to lose control. So a certain aspect of neurodegeneration is cells and their connections are actually dying and diminishing as part of the disease process. But a condition like depression, it's not necessarily the same thing. You know, you look at the brain, 100 billion cells, 10,000 connections per cell. There's a network. There's a whole complex way that the brain controls mood, and controls memory, and controls responses. So why am I telling you this? It's because now we have ways of seeing into the brain and seeing where changes in the brain occur, say during depression or during neurodegeneration. And depression, the cells aren't necessarily dying, but their connections are changing. Their connections are not as active, or the communication between these chemicals is altered. So you don't have the same control of the mood, and actually the mood control is very, very close to the movement control in terms of where the brain is. So the complexity, this is more a circuit. This is more the wiring of the brain. It's not quite working right, and so you can't control your behavior. You're consumed by thoughts or mood changes. So there's a way of thinking of two different ways of how to treat this and what the impact on the patient is.
Well, we noticed for instance, on Fiona's slide there that depression on one end just looked like the brain was just dark, and on OCD on the far end of the spectrum, everything's lit up. Is that a kind of an indicator of?
Yeah. So there's lots of different ways to look at the brain. There's measures of activity itself. I'm not actually sure what was being shown there, but there are demonstrable changes in areas of the brain, say in dementia, certain forms of dementia, the frontal cortex, there's diminished control. In Alzheimer's, there's diminished blood flow to parts of the brain. Another important aspect is the brain consumes an incredible amount of energy. If you eat one chocolate bar, about half the calories of the chocolate bar are feeding your brain. It needs 20% of all your body energy intake goes to feed the brain.
So eat chocolate.
Or sometimes think more. So it's more of this idea of keeping the brain healthy. You need lots of nutrients.
Okay, yeah.
Now, so it's possible to see changes like that in certain areas where they're not as active and they should be more active, and this is what's leading to mood control.
And how do we see these changes? How do we know that there are these problems occurring in the brain?
Well, so the problem right now in understanding depression and dementia is particularly depression and schizophrenia, for example. We're looking at symptoms, and symptoms are the behavioral symptoms, and the goal is to understand what in the brain is changing to lead to that change of behavior, and then we can start to understand, well, what exactly is the change in that area of the brain that we can maybe help alleviate to help the person recover their normal activity.
Oh, go ahead.
No, go ahead. No.
Well, there was this one graph that talked about age, for instance. How age affects 10 to 20-year-olds, and we were. Can you see this in these kinds of scans? And
there's a very powerful image. The graph that Fiona showed mental illness in particular. That graph peaks development between 10 and 20, and this really fits into what we know about how the brain develops. When a child is born, you can see as a child develops over the first 5 years, lots of changes. A child can walk, can speak, and becomes a lot more aware of the surroundings. But it's very interesting that in the teen years, there's another secondary intense development of the brain during this time period of 10 to 20 years old, where the connections, it's called the frontal cortex, is part of the brain up here, makes connections, develops their connections throughout the brain to the rest of rest of the parts of the brain to control behavior. And this controls executive function. Executive function means thinking. If you speed in a car and you've had too much to drink, you're going to have a bad problem. And it takes a little thinking that the future may be really bad if I do this right now. This develops slower in boys than in girls.
Well, we all know that.
You all know that. There's more risk-taking. You realize, well, if you do something risky, it will have a bad consequence. It takes a little while for this to develop. And one thing that really alters this, the success of these connections developing is stress. Stress, chronic stress, as everybody goes through when they're a teenager, dealing with society, learning a way in life. It's a very stressful time. This does have an impact on this time of connections.
Well, I just, so you all know, my congregation knows this, but I've struggled with depression since I was a young person. And of course, it really exacerbated during my teen years into my 20s. So I have a sense of this. But coming to this idea of depression and dementia, are they different, or is the cause of dementia the same as depression, or how do those two things? Let's focus in on those two. How do those two things interrelate, or what's the difference between them?
In a way, I think I've covered maybe a lot of that already in my rambling answers. But just to bring up the point is depression is often more a disease of the teens and early 20s. This is something that develops during this time period, versus neurodegeneration, Alzheimer's, Parkinson's, other conditions are very much a disease of age. And so there are different bases for these conditions. I think right now, so I described Neuroscience 101. Okay, Neuroscience 101, the nerve cells communicate. Well, there's Neuroscience 201. Okay, so around the nerve cells, there are support cells that keep these nerve cells, the prima donnas of the brain, healthy and working well. And these cells also communicate with the immune system. The immune system, say, if you have an infection, the white blood cells in your blood help combat the infection. So what's coming out quite interesting right now is there is potentially a component, cross communication between the immune system in the body, fighting infections, and the immune system in the brain. And this may underlie, this is thought to be, it's kind of hot area research for underlying what may cause depression, where it's altering the circuits, not actually destroying the nerve cells, but also potentially leading to certain forms of neurodegeneration. So we're trying to understand more of the brain as a whole, not only as psychiatry and neurology, but also understanding the brain in the context of the body.
Is there a connection, perhaps, then, between depression and neurodegeneration later in life?
So the typical depression, you of course see, it's more common in women than men in their late teens and 20s. But there is often associated with Parkinson's disease, where these cells in the brain are starting to die and you're losing control of movement. There is a correlation of depression with that too. This is pathological. This is not just feeling sad. This is having more pathological depression, and often there's may lead to suicide at this time because people have a hard time not only dealing with their disease, but then the inability to deal with the mood.
So what is the hope? Let's maybe turn a hopeful turn and here. But what is the hope for the future of treating depression, and what does the latest research tell us about?
Yeah, it's difficult often to talk about neurodegeneration because it is tough. It is, there aren't a lot of easy answers right now. With depression, there are treatments. It's very important to go to a clinician and to make sure there's no clear physical link to the mood disorders. But it's often, one way to think about it is thinking of how to keep your brain healthy. And this can potentially help. And all those things our mothers told us when we were younger, they actually really are true, right? You want to eat your fruits and vegetables. The diet's important. It's good to have friends. Having a community, friends are extremely important at having reducing stress.
No one should be alone.
No one should be alone. Excellent message. And as well as, it's very important to use your brain. This is clearly an important factor in preventing decline later in life. It turns out there's some forms of dementia actually are reducing in incidence. And there's a study just came out in which there's a large cohort being studied in the States. And it's actually declining a little bit, but only with people with high school education. Sounds odd, right? So it's too late to go back to go to high school, but it more reflects the type of people maybe take better care of themselves. They're maybe a bit more aware of taking care of their health, and that's having a big impact in reducing dementia because they're taking better care of their heart, and that cardiovascular link to brain health is extremely important. And so that's one thing you can do to keep yourself healthy. A little exercise is extremely important, even in the elderly. Just actually not a lot of exercise is quite good. Maybe lifting weights, not that excessive, twice a week, or even a little bit of running, really helps to reduce the brain shrinkage that occurs with aging. But just to stress, you're not going to be able to prevent Alzheimer's or other forms of dementia by doing puzzles, or this is a disease. This is not it's not something you can blame yourself for not having trained as a violinist or done all the Sudoku puzzles. This truly is a disease, and that's different than keeping your brain healthy by exercising it.
Well, last night I spent a little bit of time preparing to meet with Brian by watching last year's film Still Alice, if you've seen this. Julianne Moore won an Academy Award for it. And there was this moment in that film where she discovered the particular form of Alzheimer's, early onset Alzheimer's she had, was genetic and was able to be passed down to her children. So all the children in the family ended up getting tested. Is it just particular forms of Alzheimer's or dementia that are genetic, or is it all genetic? And is there any way to stop it from occurring?
Great
because
question.
of that, or not really?
So there's called early onset, as this movie as an example. Early onset, people can have dementia starting maybe in the late 40s or 50s, and this typically has a strong genetic link where you have you inherit certain gene mutation, but it still is a risk factor. It's not the same as some inherited diseases. You will absolutely get it because of the mutation. These are risk factors, and so it is always important to keep in mind of keeping your brain healthy, the exercise. You never quite know what's going to happen because the understanding of dementia, schizophrenia, and other factors with an inheritable component, these are complex disorders, not caused only by the genes, but also by the experience and the environment. It's very important to think that the brain is not what's called a genetically encoded organ. So it's not that we think that the genes describe ourselves, but the brain represents a learning organ that learns from experience. You remember what I just said, hopefully, and so this is the brain working. It's working not just the genes, and so it's important to think of that component. And the complexity of brain diseases, most of them are not purely genetic. There's a small amount. They're also influenced by the environment and by life experiences.
Well, that's it. Thank you. We're out of time with you. We can go for another 10 minutes. Thank you very much.